Let's go ahead and take a look at our fraction subtraction. This is the textbook again, just reminding you of the resources within the textbook. I have a little quick learn check later on when you want to add and subtract fractions. But we're going to go ahead and take a look at subtraction now. Subtraction follows the same ideas as addition about finding common denominators, cross multiplication approach. You could see we could do this is a common denominator, so that's easy to do, right? We're subtracting, taking away, or finding the difference between. We can also use missing added approach. When it's unlike denominators, we use that cross multiplication approach. So instead of a plus, it's a subtract. We subtract that product and you still multiply the bottom. So finding the following differences, 4/7 minus 3/8. You could see I'm going to cross multiply 32 minus 21 over 56. 1156, pretty easy. Here, again, we could cross multiply or find a common denominator. 36 is the denominator that comes to mind, and it's 61 over 36. We're going to turn that into a mixed number. I think that's 21 plus 4. I think it's going to be 1 and 25ths over 36 as a mixed number. So finding a subtraction, it's the same idea. We're just subtracting instead of adding. So all those kind of rules apply to subtraction that we get from addition. So keep that in mind as you practice your subtractions. We end this chapter with mental math and estimation. So we're going to add and subtract, but this really becomes where if we don't really want to do all like the precise fraction addition and subtraction, we can use some mental math and estimation techniques, right? So from this example, again, we use those same ideas, and it's not about memorizing, it's about using compatible numbers. Don't memorize the techniques, right? We give names to it to give you a hint, but again, you may come with your own ways to do that. So range low to high, so 3 plus 6 or 4 plus 7, right? So we know that answer is between 9 and 11. It's an important process, again, this estimation, right? That students start to, it helps them think mathematically. 15 in 1/4 minus 7 3/5 front end with adjustment. I'm just going to, take the front part. We could adjust it a little bit by adding some stuff. 3/5 is kind of like 1/2, so we're adjusting. So I'm just going to use 15 minus 7 is 8. And then we have this extra half to take away. So 8 minus half is 7.5, approximately, again, right? What that is, we're adjusting, looking at the front pieces. The 1/4 I just assume is close enough to 0. Again, having understanding of the numbers. It's just an estimation. On this one here, rounding to the nearest half or whole, that goes 5/6 is close to 1, so it's 4 plus 5 plus 8.5, and so we can estimate there. Again, it gives us a good sense before going to technology of value, because sometimes I may not need a precise value. And then we end with this idea of comparing fractions using benchmark fractions. Benchmark fractions, like fractions that we know: 1/2, ones, wholes, fourths, 1/4, 3/4. And so, which is larger here in this case? One is a visual. This is 3/8 and 2/3. I can see 2/3 is larger, but we had talked a little bit in a separate video. An example popped up. 3/8 is close to 4/8, but I know it's smaller than, which is 1/2, right? So I know this is smaller. So I know 3/8 is on the other side of a half when we think about it, right? 2/3, that's bigger than a half. So then if 3/8 is smaller than a half, right? If 3/8 we know is smaller than 1/2 because of the 4/8, and we know 2/3 is bigger than 1/2, then we know that 3/8 is smaller than 2/3, right? That's the idea of using benchmark fractions. Which is larger, 5/6 or 5/9? Well, in this case, this is close to 1, this is close to a half, so I know 5/6 is going to be larger. Which is smaller, 2/11 or 9/11? Well, one way is, again, we know these are close to 0. I know 1/9 is bigger than 1/11, knowing those. So if I turn 1/9 into 2/18, we can now compare. In this case, 2/11 is bigger than 1/9 because 2/11 is bigger than 2/18. So using equivalent fractions, but again, our benchmarks, knowing these unit fractions, I know that um, in this case, again, 1/9 is equal to 2/18. I know that 2/11 is bigger, right? When that denominator is actually smaller, the fraction is bigger. So that's what we have for adding, subtraction, and then ending on mental math and estimation.